Hi, I'm Brent Yance, a software developer at LAS, here to help present the video area for the 2027 call for abstracts. First, I want to set the scene with a hypothetical situation. Let's say we're called in to help support the staff at a large museum by applying computer vision models to the network of security cameras. Well, we can certainly train models to help support their operations and free up staff time. We could use image classification models to identify meaningful scenes. We could use object detection, tracking, and activity models to alert the security staff in the case of any events they need to be made aware of. And with a recent experience with new model architectures and past projects, we've seen we can train these models to be highly accurate. These models can be applied to a wide variety of data, which in our hypothetical situation, they'll need to be. This museum is likely to have a wide variety of cameras, indoor and outdoor cameras, pan tilt, zoom, etc. But what happens when the environment evolves? What happens when things change? These models may be very accurate at first, but over time, their accuracy could drop. Let me give some examples of how that could happen. Let's say a week later, construction starts across the street. Well, now we have construction equipment, construction crews, new scenes. All of these things are anomalies compared to the past data our models were trained on, and they'd be highly likely to start reporting false positive events to the users. So now we need to go back and fine tune these models again to stop alerting on all this construction activity. And let's say a week after that, the staff adds some new cameras or fixes some old ones. Well, we now have new streams that the models were never trained on. The models might still be fairly accurate in these situations, but we likely have a very high standard for accuracy. Let's say a couple weeks after that, too, the staff reads an article about the Louvre break-in last year. In that break-in, the thieves pulled a bucket truck right up to the side of the building and were able to enter an upper floor directly. Even though a couple slides ago we just talked about dropping notifications and alerts for construction equipment, maybe we need to re-add those back just with some tweaks. And one final example. What about when it's winter a few months later? Well, we now have different lighting conditions, different backgrounds, different vehicles again. You're seeing a pattern here. We might need to find new data, label it, retrain new models, and deploy them once again. So you're starting to see the challenge here. This change isn't avoidable. These environments change over time. This isn't a bug, this isn't an exception, this is every case. But this manual labeling is clearly unsustainable, even for this one museum deployment. The museum staff aren't likely to have the time to label lots of new data every time something changes, especially when the purpose of the system was to save them time. And us as the model developers aren't likely to be able to label all this data either. There are probably privacy concerns first about them shipping the data back to us. And even if we had it, we're also likely to be deploying models to a wide variety of data sets, not just this one museum. So we're also not likely to have the resources to fine-tune these new models manually every single time. So what's next? How do we improve this situation? Well, now is when we get into what we're calling for proposals for 2027 in the video area. And I have it split into three sections. First is soft labels for video triage. Second is adapting pre-trained models at the edge. And finally is just understanding a video corpus. So first is soft labels for video triage. This is how do we improve our models over time? How do we make today's model better than yesterday's? We're likely not to have a lot of explicit feedback. We might have a couple of examples. Your models missed this thing. They're not as good on this stream. There's a new object type we need, but we're not likely to have thousands of labeled images every time something changes. So first, how can we make the best use of that data and fine-tune models based on limited explicit user feedback? Second, how can we supplement this with implicit feedback? Can we identify with user activity in our apps, with the change in data distribution over time, more information we can use to improve our models? And finally, can we train models that can adapt based on changes in the data distribution itself? Do we have to provide feedback to the models, or can we use information about how the data set is changing over time to have the models improve themselves and adapt over time? The next area is adapting models at the edge. This covers research areas including monitoring models at the edge and improving models at the edge. When I'm talking about the edge, I'm talking about laptop tier hardware here, not data centers, not microcontrollers. But we mentioned before, as model developers, we're not likely to have either the resources nor, for privacy reasons, access to the full data sets themselves at each of these use cases that we're using our models for. So how can these models on site at the museum in our hypothetical example be monitored? How can we see how well the performance is doing over time? What metrics do we need to be looking at? And how can we improve the models there versus having to ship large data sets back or ship models back and forth every time? How can we fine tune these models? How can we improve them over time? How can we make sure they're doing their job? The final area is at a high level understanding a video corpus. This is how do we get answers to a wide range of questions without training custom models for every use case, for every question. For example, and back to our hypothetical, maybe the museum administration is curious about the parking situation. Are visitors having to drive around the parking lot for half an hour just to find a spot? Well, this is something that might be interesting, but not something we can train custom models on for every question users might have about the data. We could also be interested just in video summarization at a high level. When the next shift of security staff comes in, what happened yesterday? Is there anything I need to know about? If they do decide to look at videos themselves, can we prioritize the data for them? Can we use things like drift-based anomaly detection? What's new? What's different? What do I need to look at? How can we prioritize that for users automatically so they know they've identified anything that they need to know about without having to review, say, hundreds or thousands of hours of video across all the cameras? Finally, some takeaways. As we mentioned before, environments evolve. We can train models that are likely to be highly accurate up front, but over time, their accuracy is likely to diminish. And with a high standard for what accuracy looks like, we need to make sure our models can keep up. We're interested in ways of improving models over time with limited manual intervention. We're not going to have thousands of labeled examples every time something changes. How can we make best use of the limited labels we have? How can we supplement these labels with implicit labels? How can we adapt models at the edge? How can we understand our video data sets at scale without training custom models for every use case? If you have any questions, feel free to reach out, and I encourage you to read the rest of the 2027 Call for Abstracts. Thank you.